So this new chapter is about memory. Okay, so this memory, what is the memory? The memory we're talking about is actually two places that we can talk about. One is inside the process, we call it user space memory. And another is, the process associated with a bunch of memory inside the kernel. So we can also talk about from the kernel point of view, okay? So we will start talking about it from a user space point of view. So what is the meaning of user space point of view? That means that you are the programmer, okay? So you write program, you need memory, right? You declare variable, you call function, you call malloc, doing recursion, okay? It's all about memory. So we are talking about this part of memory. So basically this part of memory consists of a bunch of data. So basically we will visit all of them. I will disclose to you every little secret over these guys, okay? They contain many secrets, particularly in the malloc part as well as the global variable. You will have something that you have never heard of, okay? So maybe you have heard of it, but you don't know about their own identity and secrets, okay? So first of all, anybody don't know these four guys, okay? If you don't know these four guys, I yeah, kind of late, but I may let you drop it, okay? Yeah, so well, these four guys should be familiar, okay? Don't tell me that, oh, I'm a C# programmer, okay? I don't care about what is a global variable. Yeah, I know this way OO is there's no global variable, okay? But basically, running OO is calling a lot of new, something like that. It's actually malloc, okay? Because most of the OO type of language cannot compile directly into executable. It will go through C, okay? So that means that what is this layout? This layout is actually for the CPU to read, okay? CPU knows this layout, and that's why we have to understand this. It's not about how to write a good Python program, how to write a good Ruby program, because eventually you will need the memory. And let's say some people ask you, hey, I remember this very clearly. Student taking my course, okay, and after that, let's go to summer internship. After they come back from the summer internship, they tell me one very interesting thing. They tell me that, yeah, UST student sucks. Yeah, I know, okay? Yeah, how sucks is this, okay? They don't know what is the limit of a process that can host how many memory, okay? Basically, their task is to do a video encoding. I still remember this because I know that firm, okay? So they do video encoding. They find that they cannot malloc reach certain limit, okay? And that USD student don't know about that limit. Our student know, okay? Yeah, then you know who to debug, huh? Okay. So yeah, it's not about promotion or something. It's just summer internship, okay? But yeah, it's kind of weird that no one talk about this kind of limit and classification of memory. So we will start with this, and by the end of this part, you will understand what is segmentation faults and how to generate segmentation fault effectively, and how to avoid. Okay, avoid means that you stop cursing that, yeah, my program works on my computer, but not on your computer. It's your computer's problem. No, stop cursing. Okay, it must be something wrong in your program. Okay, and what are the things that is possibly get wrong? We will go through it one by one. Okay, so first of all, it's about addressing. So addressing means that inside a process, okay, you have an address space, right? So what is the address space that you can use? So this is a program. Maybe it's a little bit hard for you to look at this kind of thing, okay? I will show you the code first. If you have a computer, you can run the thing together with me, because my computer is 32-bit. Maybe your 64-bit computer have different addresses, okay? So my 32-bit computer is my Linux, okay? So what I'm going to do, I launched the program. What this program is, you will see a bunch of things. We have a global variable called global integer. What else? We have a pointer, okay, which is integer pointer. I don't care what type of pointer it is, as long as it's a pointer. So do you know the pointer is storage type? Yeah, I don't know how good you have learned C, okay, maybe 2 or 1 year before, okay. So pointer is a type, is a storage type. Its job is to store an address. So if it's a 64-bit CPU, then you will store a 64-bit address. If it's 32-bit CPU, you store a 32-bit address. So whether this is int, asterisk, char, double or whatever, as long as it's pointer, then you can assign it from one to another because they are all of the same type. Just for it to be CPU, the 4-byte address. Okay? So here, I have malloc. Some people argue with me that hey, we need the casting. I will say no. Okay? It's actually don't need the casting because as long as you're copying address, that's cool. So here I don't do any casting. I point there. Now it's save an address. And as long as we have this bunch of things, we can access their own address, right? By using this address operator. So still remember the address operator. So what I'm doing, actually I know that the first line is a local variable. Maybe a highlight here is easier. So it is a local variable. Remember malloc pointer, although I used it for storing a malloc address, but itself is a local variable. So I print its address, so it is a local variable. Then a read is store address, so it must point to another area. It's a malloc memory area. Next is the address of a global variable. And what is the things here? The things here is a constant pointer. So what is a constant pointer? Where can you find a constant pointer? Yeah, it's something here. I don't know whether you know it or not, okay? Every constant, okay, as long as you know assembly, then you will know. If it is a constant, then every constant will be hard code inside of what we call the codes and constant area. Okay? If the magic is if you have several hollow string, okay, clever compiler will make it into one. Okay? So as long as they are the same. And last thing, do you know what I'm doing here? No, you don't know what I'm doing here. First of all, do you think that if I write something like this, I can compile it or not? Who think that I cannot compile? I can compile. Then my compiler will corrupt. Then what is that? There's only one thing I can. And people think that I can corrupt. Not can I compile. No response. Okay. Yeah, go ahead. I don't care. So let me clean it. Okay. So this is the program called address. Make. No problem. So what does this mean? Maybe you are new to pointer. We call it function pointer. Whatever functions you have written in a program, you can read its pointer out. Okay, which is address. When you write it here, that means that it's an address pointing to the code representing that functions. Okay? Yeah. So to your surprise, maybe you can think of, yeah, actually we can write a recursion and main calling main. Okay? Yeah, because you can always access your pointer address by the program code itself. Okay? So let's run, and what you will see here is a decreasing address. And I don't care this too, okay, because I don't know whether the constants come first or the main come first, okay? But you can see a decreasing trend, right? Is it? Am I right? I didn't look it carefully because I always believe in what I learned, okay? If I learn is wrong, it's not decreasing address. So what is the meaning? The meaning is actually this map. This map, okay? So you will see the results of the stack or local variable in the first place. So here is the local variable, right? First time you see local variable address, then you go down, and the difference is so huge, okay? One order less, and you will find malloc memory. Very close to malloc memory, we find global, right? And then after global, we find code or constant. I don't know which go first, but they kind of are close together. Okay, you can see this prefix. Wow, very close together. The thing they are aligned in that way. Okay, it is an Intel CPU layout. If it's you're using another CPU, very old CPU or ARM CPU, they give you different layout. Okay, but this is the most common platform and the things that you can try on every computer, not just Mac, Linux, but also Windows. Because Windows usually use Intel CPU, right? So this is a layout. The layout doesn't mean anything. It's just a piece of facts. Okay. Now, to calculate the addresses, now this is something that many people ignore it, okay? So what is the address? Address in 32-bit CPU with 32 bits. So I can only calculate up to 32 bit. Don't ask me to calculate 64, okay? I cannot just name the value, okay? The value here I know how to name it, okay? So the configuration is very easy. I don't want to go through it. Just want to tell you that from 0 to its maximum address, okay, we have 2 to the power 32 variations, right? Because we have 32 bits. So the 32-bit variations give you the largest address. Remember, every address means 1 byte. Then you go to the next address, means next byte. So it's a bytes addressable memory. Then every representation represents one particular byte. We have only 2 to the power 32 distinct bytes. So what is the meaning? The meaning is if you have a 32-bit CPU, you only can support how many? 4G minus 1 byte of memory. But maybe you want to ask a question. Hey, it's not, right? How many memory you can buy now? Yeah, you can buy one memory chip of how many? 8 gigabyte maybe, yeah. And then you have 4 slots, okay? You insert 4 times 8, 32 gigabyte, okay? And I can even use 32-bit operating system with 32-bit CPU. Why we have this? Okay? Now you have to be very clear what is the difference between this address and the memory that you can buy from the market. Okay? The memory buy from the market is a big reservoir, okay? Big tank of water, okay? And here is just a small cup for your process. Understand what is the difference? You have a small cup of water for your process, and there are many processes sharing the big tank of water. Okay? So you can have a very big tank, very huge amount of memory that you can plug in. I don't know, maybe you have 1 T of memory, okay? You're super wealthy, okay? You're Lee Ka-shing, then buy 1 T, okay? Go ahead. And yeah, I don't know whether you can use it, okay? But in each process, okay, then each process has its own addressing limit. It's because every byte you can talk about inside the process is following this from 0 to XX, XF here. 0x, sorry, 0x, XF here. Okay? So this is the limit. Okay? If you're clever enough, you will hear some contradiction in what I just said. Okay? Yeah, later on I will solve that contradiction. If you find that what I'm saying is something contradictory. Okay? So now, what is next? Next is, if I understand, yeah, this is for one process, okay? And for the memory, it's a big reservoir that can serve different processes. So that's why for every process, let's say we have one process running using 1 gigabyte, okay? Then we have not 1 gigabyte would be too much. 64 gigabyte of RAM plugged in, okay? Then we can support 64 processes, okay, at most. Don't forget that the kernel is also doing something with memory. Okay, so this is the limit. If it's 64 bits, then 64 bits I cannot calculate it because it will become much wider. Okay, and I cannot derive such beautiful calculations here. Okay, so this is 64-bit, 32-bit limit. Any questions? No? Then we'll go ahead to talk about some very brief introduction, really very brief, okay? The instructions, okay? So instruction itself is just some bytes, okay, inside the machine code. Now you know that we can, it's the code. We can access the pointer here. So that means that we can actually use this pointer and dereferencing operator, dereferencing as asterisk, okay? Then we can access every byte inside the function code. Yeah, no problem, huh? But nothing, okay? But it's nothing. It's you're decoding those opcode, operand, okay, to read it out as a machine code. It doesn't make any sense at all, okay? Then we're talking about pointer. Just a very brief introduction. How many of you still play by pointer? So that means that you are all playing pointers. Do you know what is the difference? Playing by pointers and playing pointers. Okay, I am the one who playing pointers. Okay, pointer is just a piece of cake for me. Okay, you give me a a very, very horrible program to me. I know what is going on. Actually, it's a piece of garbage. Okay. Yeah, but yeah, if you're not at the level that you're playing pointer, you're playing by pointer. Now, don't be afraid of what is a pointer. Pointer is a storage type. Okay, as long as you understand that it's a storage type, then you won't be afraid that, oh, what is the meaning of here? It means that, oh, you're storing an address. Okay, now take a look at here. I do it on purpose. I set up a pointer storage and you store an address of a particular variable. I don't care what is a variable location. It can be a local variable in this orange area or a purple area global variable. I don't care as long as you have that storage. Now, why you always get a segmentation for using a pointer is because you store an address there, but that address, when you store it, has some problem. Okay? One of the most effective way to generate segmentation for this guy. Okay? So this guy is, you can try. Pointer, PTR, okay, this definition. Okay, declare pointer equal to 10. Do you think that it's work or not? I told you, this is just storage type of address. Then you should ask yourself a question, what is an address? Address is a number. Do you think that I can compile this program or not? If I assign asterisk pointer, this pointer of integer type equal to 10. Who thinks yes? Who thinks no? No. Then what kind of no? Is warning or error? Who thinks it's warning? Okay, one warning. Error or two warning. Error. Error. Okay, so error means that I just writing garbage. Okay, let's try. Okay, seems that you are not naughty enough. During my time, I will try everything, okay, and ask the tutor, and the tutor really hates me. He said, yeah, shut up, don't ask, okay. Okay. Time for the truth, huh? Ooh. Make this program. Oh no, maybe make is not good, huh? Let's turn on all the warning. Okay? All the warning. Switch off all the optimization so that no code will be optimized. Test.c minus O test. Okay, let's go. So what is that? You can still compile the executable with a warning. So the compiler already tell you something wrong. What is the thing it is wrong? It's saying that it's just a 10, okay? Why you insert the 10 value inside the storage of an integer pointer type? Okay? So I don't care. I don't care. Eat that. I just said that it can be anything. Okay, yeah, it's just a void asterisk. It means that generic pointer. Generic pointer can be a pointer of anything. Yeah, it is. Still, what is the warning here? Does it warning matters? Now it doesn't matter at all. Previously, we have warning saying that you're making an integer become a pointer, which is a dangerous call. Huh? Now, next, I said it. Yeah, I cast it to any type of pointer. I don't care what type of assignment statement you are, as long as I'm an address on the left and an address on the right, then you should allow me to finish the compilation. And it says yes. Okay? Now, first of all, do you think that after I assign this value, I will have segmentation fault or not? Cat. Okay, I can compile it. Now, do you think that I will have segmentation fault or not? we think yes. Or any kind of error. Yeah, even before the computer. No. The one thing there is an error. So what do you think? We'll get the output, hello. Why? Yeah, don't be so puzzling. Yeah, this guy always showing some tricky code. Yeah, don't answer him. Okay. Yeah, it should be okay. Yeah, it's easy, right? Now, what I'm going to do next? Yeah, of course. The reference. The reference is the monster. Percent D. Okay. Dereference it. So it means you follow 10. You follow the address 10 and go to the location that we have the address code 10 and retrieve the things out. This is read. Okay? One more. This is write. Okay? Let's confirm it. Let's confirm it. Okay? One more hello here. Okay? So what I'm going to do, I want to show you, you have read, we have write. Do you allow to read the address 10? If yes, then I will print something out and continue with one more challenge. Do I make something really make sense if I write to the address 10? I follow the address 10, I found the memory, assign 10 in there. Then if yes, then I will see one more hellos. So, make a choice, 3 choices. How many hello will I see? 0, 1, or 2? 0 means, yeah, I already have a problem and a segmentation faults. Right? 1 means that I will get past the reading of the address 10, okay, but I cannot pass the writes. 2, it means that crazy. Address 10 is a random address that I think of and I even read and write it. Now, pick a box. 0. Okay, 5 of you. 1. Also 5. Interesting. 2. You guys make sense. Okay. At least you don't think that. Yeah. What you think of a 10 address and then have some interesting results? Okay. Now 1A, no 1A at all. No optimization. So even though I write garbage code, it will be compiled. And when I run it, 0. Okay, 0. Yeah. For the guys who vote for 1, actually you are close to some other answers. Well, first of all, there are some address that's totally illegal. Later on, I will tell you 10 is a part of a piece of address which is totally illegal. You cannot read, you cannot write. Now, some addresses you are allowed to read, but you cannot write. Okay? Later on, I will tell you all of that. Then you will understand, hey, how can I generate segmentation faults? Okay? So don't be afraid of address. Address is a piece of storage. As long as you are conscious of what is being stored inside the address, and while you dereference it, where you are talking about, then you won't have segmentation fault. And once you have segmentation faults, then you understand, yeah, must be some dereferencing is having some problem. Then you try to debug it, inserting printf surrounding all the reference statement. Then you will quickly locate a particular region that you have a problem. Usually it's because of dereferencing. And after you know dereferencing is a problem, that means the previous assignment has no problem. Okay, then you can trace back very effectively, not just standing there and someone helping you. Okay, yes, no one will help you during the midnight. Okay, so next we will go to any question first of all. This just dereferencing. Usually it's because of dereferencing. Show you the problem, but the problem is from the time that you assign the address. Okay? So then we look into the code and constant. Now this time you have to ask your neighbors for some. This is just an introduction I was given. Ask your neighbor for some help. This program, I have some questions over this program. What this program is about? Yeah, read for a while. If line 5 is okay, then what I'm going to do? Yeah. If you cannot read it, ask your friend for your help. Okay. If both don't know, okay, then I will talk about it. Don't worry. Yeah. Yeah. Just spend some time to understand it. First of all, do you understand what line 3 is doing? Line 3 is a hollow string here. Okay, this hollow string and this hollow string is supposed to be the same. Okay, so these two guys should give you the same result. Previously, I already told you that if the string is the same, then no matter you write how many times, actually we have two hollow strings. Can you see it? One is assigned in line 2, one more in line 3. I write it down there. So usually it's only one piece of it. So line 3 and 4 should give you the same outcome. But they're different. How different are they? One is a totally constant, no matter how you argue, it's totally constant, and other is not a constant, right? And other is you're using a pointer, and a pointer store an address of constant. Okay? Later I will evolve this program a bit, and then you will, the entire class will fail to understand what is going on, and just stand there and what it is. Yeah, this is okay, this is still okay, right? But this is the difference. One is a pure address from the string. One, I just assign it to another variable. Still, it is a constant. Then I ask you these questions. After line 5, what will happen? Now, let me ask you some options first. I'll give you some options. First, I cannot compile, so I cannot run it. This is first option. Second option, why I cannot compile? Because you are assessing a pointer to a constant. Okay, the compiler is so clever that it know that you are addressing to a constant. Second, you can compile it without any warning, but you cannot run the program. When you run the program, segmentation faults. Third is nothing happened. Just print out what I want from hello to hell. You understand this program? If line 5 is okay, then I will change hello to hell. I just remove the O. Okay? Which choice? 0, 1, 2. Zero choice. That is nothing happened because I cannot even compile it. 1 is I can compile it, but I cannot successfully run it. 3, nothing happened. I just run it through and have hell. 0 choice, where's the heck? Cannot compile. Okay, everybody figure you can compile it. Okay. How about the middle choice? I've got segmentation points. No, remember this is a tricky program. This time I tell you this is tricky program. How about I can run it and print out? Okay, a few of you. Very good, very good. Okay, that means that you have tried something, huh? That's it. We have two programs. One is called constant pointer, one is called constant array. Constant pointer. So this is the program that you've seen in the part 1. No difference. Compile. Oh, don't use this compiler. Let's type. Okay. Pointer.c minus O. Okay. So no one choose this choice. I can compile. Okay. Can I run it? Go. Now first, the two addresses are the same. Okay, as expected. You cannot run. Why? It seems that it's strange. I heard a lot of people telling me that yeah, pointer is an array. Array is a pointer. Now I demonstrate in this program, right? I use a pointer to say the starting address of the string called hello. Then I use pointer arithmetic. Actually, it's pointer arithmetic. Use the index operator Then I go through it one by one, and I reach the O character. I want to remove it. Now, what is the result of dereferencing? If I just want to print it out, is to access each pointer address the reference 1 and get H, move by one more character, dereference again, then get E and L, L, O. Actually, I'm processing the things over the constant. And you try to modify the constant actually. Because when you dereference it, you are pointing to the constant area. Okay? So don't be frustrated because I will show you another program. Even more frustrated. Okay. What's the difference between this and the previous program? Okay, so version 1. Okay, version 1. No. Version 1. Version 2. What is the difference? Only one difference. Photo hunter. What is the difference? Yeah, which line? Which line? In the main, starting from which line? Or the difference happened on which line in the main? First line, right? First line of the main program. I changed the string data type from pointer storage to array. And this time, what do you think? Can you compile it? If you can compile it, can you run it? I should ask, can I compile it? If no, will I get segmentation faults? How many of you think that I cannot compile it? And usually people will tell me, yeah, you missed out the size of the array. Of course you cannot compile it. Yeah. Can I compile it? Okay, do you think that you can compile or cannot? Can, okay? So other things cannot. Right? How many of you cannot compile it? Yeah, no one raised their hand, right? Next. How many of you think that we'll have segmentation faults? We will have segmentation faults. Yeah, remember, the two programs are just so close. Will I have segmentation faults? Only one think that. How about others? You think that no segmentation fault? Then next questions. Do I have the outputs as hell? Yeah, this is tricky, yeah? Yeah, many of you think that we will have hell. Okay? Let's do it. Again, use the safest way to compile it. Yeah. After this exercise, you start to think that you don't understand C. You think that you understand, actually you don't know. Oh, constant array. Now let's go. I can compile it, okay? Run. No problem. Okay? Now you should ask one question. Hey, what's the difference? What's the difference? Yeah?
String is immutable.
Yeah? What's the difference? Yeah?
String is immutable, so every string it just stores one.
So you're talking about the first version, right? First version is immutable. So when you touch it, segmentation faults. Now how about this one? Am I touching the string, constant string? Yeah, that is the problem, right? If you understand why I get segmentation faults in the first program, it's because I'm touching something immutable, as our classmate suggests. And here is also touching something immutable. Huh? Huh? Again here.
These two pointer address is different.
So you mean the second version?
Yes.
The first line?
Yes, you just print out.
Yeah, I print out that. I want to understand why. I know that I can print it out. Why? Give you one more hint. This course is just like a set of puzzles. Give you one more hint. What do you think? If it's a pointer, then it's 4. If it's not a pointer, it's not for. Let's do it, huh? Okay, remember I just add the size. Compile. Run. Why 6?
Because hello and then the slash.
Yeah, non-terminated. Hello, 5 character. So what's the meaning? The meaning is, any suggestion?
It breaks down the initial string into 6 characters and store it in that way, so it's not immutable anymore.
Yeah, it's actually a copy. Okay, thank you. Good answer. Actually, you are doing copy. This is string copy. And the compiler is so clever that because it is by compile time we can define how big the string is. So we know that there are 6 characters needed, including the null terminator, and it is string copied to an array, and that's it. No problem at all because we're doing copy, and the memory now is in the local variable sum. Okay, so you can change it. See, such a few byte difference already make a big difference, huh? So yeah, you start to want to go away, huh? Don't have us see anymore. Okay, next time you tell your interviewer, okay, maybe you later go to the interview. Yeah, I don't want to just see anymore. Huh? I've changed the JavaScript. JavaScript better. Okay, yeah, JavaScript also very bad. Okay, this is the program, huh? And one more. And this is more easier to understand if you understand previous one. What is this program? And this is much easier after the first trial. Night 2, what is night 2? Remember I just said you can print the address of bank, right? It means that line 2 is actually using that address access to the pointer type, and which is called generic pointer. I don't care about the type. I just store pointer address. Memory address. Okay, so it's memory address storage type. Then what is the meaning of line 5? I'm reading machine code. I'm reading machine code of our function. Okay, and read the first byte of the function. Line 7, I'm updating my program. Okay, yeah, I don't like that byte. Okay, please change it to 0xFF. Okay. So what is the meaning here? It means I first dereference it as a char, 1 byte data structure. Okay, and not dereference it, but follow this address. I know that it's a char, so please update 1 byte for me. If it's an integer, I cast it to unsigned in, then you will update 4 byte. Okay, because integer is a 4 byte data structure. Now, this is a 1 byte data structure for char. So when I follow this and try to update, I will only make 1 byte change. Okay? What do you think? Again, free choice. First choice, you can compile it. Okay? Because changing the code is a disaster. Second is you can read, but you cannot write. Because it's a piece of code. Third, it's just vowels. You can even write to yourself. And you know, some vowel is doing something like that. I heard of some very old story that the vowel is actually as encoding itself first of all, and then the vowel is running and decoding itself. Okay, genius. Okay, which answers cannot compile? Can run but cannot write. It can read. Sorry, can read. Okay, can read and write. Only one. Okay. Or maybe he's got the answer. Don't think that you know this course is start to be. What is the program name? Access code. Okay, I use this way. Okay, ACCESS code -O minus O. Now compile, no problem. Run. Okay, so when I can write to myself, you can write to yourself. Okay? So, the reason is the same. Because constant, you try to modify constant, previously modify the hello. Hello is a part of the code. You cannot write to it as segmentation faults. Now the code is also the same. So, what is the conclusion? The conclusion is code and constant area is read only. You cannot write. You cannot write to it. It's just not like normal memory. Okay? So normal memory, there's a stack, okay, there's a local variable, the global variable you can read and write, but here it's not. So it's actually telling you one side of why you get segmentation faults. Let's say your address so happen that you fall into the range of the code. I don't know why you get that address, but you fall into the range of the code. Then you find that your program starts to behave abnormally. You can read some part, but you cannot write. That's why. Okay? Maybe you have tried it. I can read it, but write a get segmentation faults. Okay. Next, data segment. Okay, data segment store what? We're storing global variables. Okay, so we actually have two types of global variable. One type is called data. By itself, it means that it's some data being initialized in your program. Okay, in your program, you initialize some data and you compile it. And because you have some data in the code, so that data will be also copied to the binary, to the executable. So we call it data. Another is just symbols, a set of symbols. So what is a set of symbols? That means that you create a global variable, but you don't initialize it. So I don't know how long that variable is, okay? But as long as you don't have any memory, you don't need to compile anything and put into the binaries. Now let's demonstrate now. Okay, I will skip this first because for the time, I will show you the most interesting example in this part first. What is the most interesting part here? Take a look at this two program. What's the difference between these two programs? Yeah, it's the array, right? You have different array. Different array, one is bigger, one is smaller. Now, what is the initializer here? Do you still remember what is the initializer there? I just write 10 there. It means you initialize the first element to be 10, and the rest of it will be automatically initialized to zeros. Okay? So when I compile this program, what happens if I type ls over the two compiled code? Okay, let's go. Interesting program, huh? I can make this time, okay? Make data, what's the name? I can't remember. Data small and data large. Large. Okay, finish compile it. Okay, so let's take a look at the code first. Data small, data large. No problem, huh? Let's take a look. Data small, not .c design as the compiled code. Let's take a look. Can you see the difference? This is the size. It's bigger. Okay? Then what I'm going to do next? 1024 is 1K. 1024 is type for instance is 1 byte. Multiply 1024 again is 1 megabyte, sorry. 1K, 1 megabyte, and then 1 GB. What will happen? What do you think? Compile? Can you see a compilation takes so long? Usually compilation takes 1 second. Oh, sorry. Memory resource? How many RAM I have? Oh, I'm using small machines. No problem, no problem. CS department have many good computer. Let's go to CS department. Wow, what happened now? Did I go online? I should go online. Okay, don't worry, yeah. We always have other ways. Yeah. Okay, so we are going to CS department. Okay, so we're in CS department. Let's go to one of our powerful machines, maybe 17. Okay. 3 minus m means showing how many free RAM we have. We have 46 gigabyte of free RAM on this machine, so must be enough, huh? Okay, so I go to that /temp and write the program here. Okay, standard. Oh, then array size, char. Okay, data. 1024 times 1024 times 1024, 1 GB. Okay, remember, initialize it. Okay, have a main. The main contains nothing, it's okay, as long as I don't turn on optimization. CCC minus O test.c, turn off optimization. You never see such a long compilation, huh? Why? Why does it take so long, huh? When I run it, perfectly fine. The file size. Okay? There is a command called du to see the disk usage of this file. This program is 1.1 GB large. Okay? To see the power, what is the meaning? The meaning is I already tell you, but when I talk about the definitions here. Data is something that you want to compile with the initialized global variable. Then it will keep in a global variable zone called data. Now, when you initialize something inside a program, then the program has to be that big in order to put everything inside the executable and load it in the memory while it's running. Okay? So this is data segment, and maybe to your surprise, during the time of very old time, okay, let's say you're playing Nintendo program. Actually, they are coding all images as an array, hard coding global variables. Yeah, they hard code the big maps, they hard code all the things, the game map, okay, all as global variables. So that you will compile. I don't know whether you've heard of you can copy games in Nintendo, Super Nintendo, or even PS. Okay, the size of the program actually grows. It's because it depends on how many data you hard code there. Okay, the more you hard code, let's say in this program, the more you hard code, the bigger your program is. Okay, so maybe you're not old enough. Okay, if you're old enough, then you heard of it. Yeah, some of the game is very small. Only one file game, okay, 1 EXE, several hundred Ks. Sometimes 1 EXE is huge, 1 G. It's all because of this. Depends on how many hard codes you have inside the global variables. Okay? And of course, when you hard code in the local, we also have this problem. Okay? But later on, I will tell you why we seldom hard code in local. We usually hard code in global. When you talk about the local variable, we'll talk about the limit. Now, give you one more number before we leave. The number is called ulimit. Ulimit is I know that you cannot see clearly. Okay, ulimit is a limit for every program one in this shell. This shell has a limit. Minus A means show all the limits. Can you find out the data segment limit for me? Can you find out data segment limit? Unlimited. Can you say data SEG and then size? So what's the meaning? The meaning is global variable range has unlimited size. Okay? Go home, try the following things, and tell me your answer. You try to write a program. Okay, first of all, make sure you have enough disk space. write a program with an array of 3 GB, array initializer, 4 GB initializer, okay? And don't try more, okay? You'll run off this space, okay? Or you play something with the hard disk, okay? It's your problem. Yeah. Try different array size, okay? And come back tomorrow, tell me whether you have successfully compiled or not, okay? I will show you some case that you can compile successfully, some case you cannot, okay? So it's not because of the hard code, but because of the CPU architecture, okay? So this unlimited is not really unlimited. See you next time. See you tomorrow.